Okay. So very quickly.
Just lean your laptop up a little bit.
Wow. Very quickly. So we'll not be wasting much time and use the time in a productive way. Welcome to our 11th class. I'm glad that we're still strong in the numbers. So we surprisingly got a very stubborn group. People who really want to learn difficult language. So today we will be learning about struct and custom types. Is that correct?
Yeah.
Good. So
I'm going to do that bit, don't worry.
Huh?
I'm going to do that bit, don't worry.
That's fine. I'm not going to go any deeper. First of all, obviously thanks to Oliver for arranging all the, drinks, pizza, space, and for Tristan to leading the class. For new people, and just a reminder, our classes are weekly. We're on site, as you are here, and as well on the internet. And obviously, if you know people who wants to study, just pass them their details so they can follow up with us. You can catch up with sessions, obviously, on our YouTube channel. Go to our website for more details. Speaking of website, we are looking for a person that can help us build a website. So if you want to have a open, like a project, yes, to put in your portfolio for good cause, come back to us if you think you can lead such a project and complete that. Yes, we're looking for WordPress type of website. Let us know, and hopefully we can build something like that. RSVPs, 17th and 24th, so our next two classes. Yes, they will be back at Skills Matter. So please do the RSVP as soon as possible. Yes, same reasons as before. If we do the RSVP early enough, we might get a bigger room. If we do late enough, then we will get the very small room. So depending what you prefer, yes, let's do the RSVP. At the moment I'm out of the licenses, so if there is anybody who is unlucky enough not to have a license, I keep you in mind. I'm really sorry. The person who deals with the licenses at JetBrains, apparently she is on holiday, and I think she'll be back. I'm not sure. I think this week or last week, but Till didn't come back to me yet with the new batch. Apparently, I was supposed to get the licenses. Like when I run out, they notice there is 20 activation or whatever they give me. They should send me automatically new batch. But didn't work out for whatever reason. Put your tick. There is a page with the name. So if somebody didn't put a tick or your name is not there, make sure it's there so we can have a list. The list, again, as a reminder to everybody, the list is to help you. It's not for us. It's more for you. So let's say if you go later on for the to apply for the position, or go to your boss and you say, I should have a raise. You should pay me more money. Why? Because I've been studying with C++ London Uni. You can go there and see how many classes I attended, and at the end you have a chance as well to do the project, which will give you the diploma. So it's a way of putting this in a more legitimate way, so that you actually did something. And obviously, once we've finished with today's class, everybody are welcome to go to pub and buy these two guys, a meal and a couple of pints, saying thank you for their effort. Sorry. That's all from me, and I'm passing to Tristan.
Oh, sorry.
Okay.
Sorry, Tristan.
Yeah.
What's the internet password?
On the wall there. Yes. Thank you, Tom. And thank you to Ollie and Justin for arranging all this. I know it's not ideal to keep moving locations, but this is pretty nice today, and we got some pizza, so thank you to them. Right, let's get on with it. Is there anybody who's here for the first time today? You, welcome. You are
Torben.
Torben. Well, welcome. So this is session 11, as you probably gathered. So if you want to go back and look at
things we've already covered, well, it's all on our website or on our GitHub repo, so all the previous slides and all the videos are on YouTube as well. So if you feel a bit out of your depth today, don't worry. We'll do what we can to help you. And there's all our old material is there as well. Which obviously goes for anybody who's watching online as well. We do have our Slack channel. If you want to come and talk to us in the week when we're not here, or just make jokes about the World Cup, which is what's been happening lately, you can join the Slack channel. Just go to that website and type in your email address, and it will send you an invitation, and then you can chat to us. We're using a textbook for this course. It's Programming Principles and Practice Using C++ by Bjorn Struct. So I assume most of you already have a copy. So this session, what we're doing today, we're talking about structs, data types, how to define your own data types. We're going to talk about member functions. We're going to talk about operator overloading. And then if we have time, we'll talk about special member functions and what makes them special. I doubt we'll get through all the material because I've done quite a lot today. And we've had a little bit of a late start, but we'll get through as much as we can. Data structures. Pretty much, well, no, not pretty much. Every single programming language that's useful for anything lets you define your own data structure. Data structures. So what is a data structure? An object. It might be. So in a kind of abstract computer sciencey way, what is a data structure?
Some kind of container for data.
A container for data? Yeah.
But it also says something about how you can access the data, doesn't it? Like streams and stacks. And
Yeah.
Organisation protocol.
Organisation. I like that word. Whoops. Don't go too fast. So abstractly, a data structure is a way to organise the data that's used in your program. And designing the data structures that we use is a really essential part of writing software. And then here's a quote. The difference between a good programmer and a bad programmer is a good one considers this code and data structures more important. Bad programmers worry about the code. Good programmers worry about the data structures and their relationships. I didn't say that. I wouldn't have put it that eloquently. This guy said it, and I think he knows what he's talking about. He also said a lot of silly things about C++, so don't take everything that he says as gospel. But in this, I think he's pretty spot on. So C++ provides us with several ways that we can build up our own data structures. And the most common is structs or classes. So if you used other languages, they probably had some notion of struct or class, or maybe both. C++ has two different keywords, but they do almost exactly the same thing. It's one notion of a user-defined type. We call it a struct or a class, but they're really the same thing. We also have enumerations. That's just a bunch of named numerical constants, really. Built into the language are arrays. We've talked about them before. The ones that are built into the language are not really that great to use. They have some unexpected properties that we usually try to avoid. So you want to use library types like vector are a better alternative. We also have unions that we're probably not going to talk about in this course. Again, using unions properly in C++ is quite difficult. They can be quite error-prone, quite hard to use correctly. But now in C++ 17, we have this thing called a variant, which is a kind of safe way of doing what unions do. But anyway, today, you can't really see it. The bottom three are grayed out. We're going to talk about structs and classes today, or specifically structs, because as I say, a class and a struct are basically the same thing.
So just to clarify, they're not the same. They're not two different words for the same thing. They are different things, but they.
Okay, so we're going to talk more about this next week.
Okay.
Exactly what the difference is between struct and class. They both define a new data type. The only difference is the default access, and the default inheritance. But with a struct, all your members are public. With a class, all your members are private. Other than that, they're the same.
By default.
By default, yeah, you can override that. And again, if you don't know what public and private means, don't worry, that's next week. So the point is, it's not like in C#, say, if you're familiar with that, they have structs and they have classes, but they're quite different because structs are value types, classes are reference types.
But access specifiers,
Yes,
public, private.
yeah, exactly. Yeah, so the difference is in the default access. So today we're going to use the struct keyword almost everywhere. Well, in fact, absolutely everywhere in today's class. You could substitute the word struct with class and just put public at the top of your definition, and it would be the same. So they're not two distinct notions. They're the same thing, just with slightly different defaults. So a struct, or a class, it's a collection of two things. We have data members, which in C++ are called member variables. Some other languages refer to them as fields. And we have member functions, which in other languages get called methods. But we have our own names for them because, I don't know, because we do. We have data members, and we have member functions. There are a couple of other things you can have member types, but we're not going to worry about those just yet. So we define a struct using the struct keyword. Give you a second to get settled.
Structs were taken over for C.
Exactly, yeah. So C++ inherits. Sorry,
C never had classes.
C didn't have classes, exactly. So way back in the mists of time in 1979, C++ was originally called C with classes. And but yes, it inherits the notion of struct from C. So inside a struct, we list its data members, we list its member variables. And the syntax for doing that is very similar to how we would declare a local variable in a function. Okay, so inside a function, you'd say int I equals 7. So here we're declaring a struct called point. So we say struct, say the name of this new type we're defining. And then we have a little curly brace to open it. And then we declare its members, which, oh, no, it is working. Excellent. It's not working on my screen. So we say this struct has a member x of type int, which we've initialized to 0, and a second member of type of type int called y, also initialized to 0. And at the end, we put the closing curly brace and then a semicolon. So after a struct definition, or a class definition, any type definition actually, you have to put a semicolon. If you don't, the compiler will complain. It will say, I expected a semicolon here. You don't have to do this in other sort of C-like languages, but in C++ you do. So that's how we declare that we have this new type. We've invented a new type, we called it point, with two members, x and y. So now how do we create an instance of a point? It's all very well saying we have this new data type, but we want to create instances of this new data type. And we do that in exactly the same way as we do with an int. So you say point p equals something. And when we've done that, we can access the struct members using a dot. So if you remember a couple of weeks ago, we were talking about vector. We were calling member functions on this vector by using the dot syntax. You can also use the dot syntax to access any public member variables. So here we've said our point P, which has two members. We're initializing it. We're saying x is equal to 3 and y is equal to 7. And now we're accessing the x member of P. And we're setting it equal to 8. Does that make sense?
Yeah, the X is just a default X, Y, Z or I, isn't it?
No, so I'm going on from the
Define the X as previously.
going on from this definition of point. Sorry, I'm going to keep using this definition of point through the following slides. I should have said that. So, two members x and y, both of type int.
You call them attributes now, or are they the same as attributes? These members, or
No, they're not attributes. Attributes are something very different. We call them member variables or data members. As I say, other languages refer to them as fields, if that's familiar to you. Oh, that's fun. That was what was happening on my screen. Anyway, yes, so we've created a new instance of our point struct, our point class. We've called it P. We've initialized our two members with the values 3 and 7. And now we're accessing the member x, and we're setting that member equal to 8.
Should point out that it's in order of their declaration, so x is going to be 3, y is going to be 7.
Mm-hmm. Yes. There's a lot of, I can usually sort of hear rustling when people get it. There's sort of, and there's dead silence, which makes me think, oh, maybe they're not.
it's just like, what's the point of? I know you said we're gonna leave this till next class, but it's the point of having a struct when you have a class is, it seems like something very similar to a class. You just a struct is very similar to a class.
A struct and a class are the same thing. They're not two different notions in C++, they're one notion, right? So the difference between using the struct keyword and the class keyword, they're almost interchangeable, they've just got a slightly different default behavior. But anywhere that you say struct, you can say class. Almost anywhere you say class, you can say struct. Yeah. So today, for these examples, I'm going to use struct everywhere, but I could equally have written this example with a class, just changing the default.
Can you define those as any fundamental type?
Not only any fundamental type, any type at all.
So reference and pointers.
You reference, well, yes, you reference members cause slightly strange behavior that I'll talk about later, but they can be pointers, they could be they could be types of other classes. So, for example, a standard string is a class defined like this, a standard vector, and we can have members that are type a member that's a vector. We could have a member that's a string.
Composition.
Absolutely, that's a really key notion. That we can build up our data structures of simpler ones. And eventually, if you bubble right up, everything's made up of fundamental types. But we wrap them up, we put them together in these user-defined types. So that was member variables, the actual data that the thing contains. But we can also have member functions. Member functions are functions which belong to the class and usually operate on that type's member variables. So again, if you've used any sort of object-oriented language before, you're probably familiar with the idea of member functions or methods, as they're called in a lot of languages. Functions that belong to a class. You've already seen, so the opposite of member functions is non-member functions. They're often called free functions as well. A lot of object-oriented languages don't have non-member functions. Java, for example, doesn't have free functions. C++ does. You can have functions which don't belong to a class. But today we're talking about member functions. So we declare a member function with the same syntax, except that it's declaration is inside.
These member functions that don't belong to a class, could you describe them as global?
They are global functions, yeah. But they're not member functions, they're non-member functions.
No, I wanted to be more specific as to what they were. Global.
They are global functions, yes.
Unless they're namespace.
Well, they're still global functions.
Well, the namespace is global, but they're inside the namespace.
So here, we've got our struct point again, and we're now declaring a member function. So, having been to several of these classes now, most of you, you'll be able to tell me all about this function. So, what's its return type? Its return type is bool. Yep. Its name is equal to, and its argument type. So it takes one argument, and what's the type? A reference to a const point, or a const reference to a point, which we've named other. So, if you can't guess, this member function, the point of it is to tell you whether 2 points are equal or not. And that will return true or false. If the 2 points are equal, they'll return true. If they're not equal, return false.
Without making copies.
Sorry?
Without making copies.
Without making copies, exactly. So this takes a reference, so it doesn't take a copy of the other point inside it. And it takes a reference to a const point, because in order to just look at it, to see where it is, to compare it, we don't need to modify it. So we take a reference to const. And then, as before, we have our two members as well. So we're going to build up this struct point over the next few slides. So we've now got two member variables and a member function. Is that all?
Or in the that it mentioned that struts are to be used for instance size under 16 bytes.
Sorry?
Otherwise, we should use class. So I'm just reading some Microsoft document on when to use a struts and when to use class, and according to their document as of 2009, it says a strut should be used for instance size under 16 bytes.
That's insane.
That,
Is that for C? It's not for C# or something, is it?
No.
Yeah,
That's-
ignore that. It's ridiculous.
That seems very strange advice, and the fact it's nearly 10 years old makes me a bit suspicious of it.
You said
as
that
well.
structs and classes are actually the same, but classes you can use for polymorphism and
Yes.
structs.
Yes.
A pure abstract struct.
A struct you can inherit from other types. So we're going to talk more about polymorphism next week. So if you just switch off for a few moments if these words don't mean anything to you. But yes, structs can inherit from other structs or classes. They can have virtual.
So would you have a pure abstract struct?
You could, yeah.
You could?
Pure virtual in C++, but yeah.
Yes.
But you don't declare the struct itself pure virtual. It would have at least one member function that is pure virtual, and then it would become abstract because it has at least one function that is unimplemented.
That would be purely abstract, would it?
Well, you wouldn't be able to instantiate it if it had a pure virtual function.
Yeah, if it has 5 functions, 4 of them are implemented, but one of them happens to be pure virtual, you cannot instantiate that. You have to inherit from it to fill in that one that's not implemented. You can mix and match in C++, unlike Java, say, which has like interface and then everything is abstract. In C++, we're allowed to mix and match. You can make everything abstract. You can make every single member function virtual, pure virtual.
In which case it would be a purely abstract class.
In which case, well, it
Yes.
doesn't change the semantics of it. You just can't instantiate it.
Yeah.
It's still just a struct.
You'd have to override the pure functions.
Yes.
Yeah.
Yeah.
Which you could do with classes.
As well.
And you can also do it with
as well.
structs.
Okay,
A struct can inherit from a class can inherit from a struct. They just have different defaults for their visibility.
Right.
Struct is default public, class is default private.
Can you use a strut to instantiate a class?
I'm not sure what you mean.
I mean, you can have a class as one of its fields, and when you construct the class, that field will also be constructed. So yes, if that's what you mean.
We seem to be getting very hung up on classes.
Yes.
Forget
yeah,
about
getting
classes.
very fancy already.
Just pretend the word doesn't exist for now, right? Don't worry about classes.
You're the elephant.
There's no elephant. There's no elephant. It's the same thing as a struct. There's the same thing as a struct. And if you really want to know what the differences are, then we're going to talk. We're not going to talk in a lot of detail because there's not a lot of detail to be said. We'll talk about it next week. So for now, forget the word class. Forget that it's a keyword in C++. Today we're talking about structs. We're keeping everything relatively simple this week. Right? We're going to talk, next week we'll talk about inheritance and virtual functions and object-oriented programming. I'm going to keep things relatively simple this week.
Sorry, one question. What's the difference between an abstract class and struct? Sorry, again, class, but
Come to next week's class. Or next week's struct. No. Next week's session. Right. I don't know why my slides are doing this, sorry. So within a member function, we can just refer to our member variables. We don't have to put any sort of prefix inside it. We can just say x and y. It's not like in Python where you have to say self.x. You can just call them x and y. That's what I mean by without qualification. Now this is one thing that is quite different to most other object-oriented languages, most other languages that have member functions, is that we have this notion of const in C++. It's very, very important. And we can write our member functions in such a way that we can call them on a const instance. So we made our point p. We could have declared const point p, which is one that we can't change after we create it. Now, what if we had a member function that was called move_to, right? That let you reassign your point so that, you moved it somewhere else. Double the x and the y or something. I don't know, I'm just making it up. We wouldn't be able to call that function on a const instant because you can't modify something that's const. So we have to have some way of saying to the compiler, this member function is not callable on a const version of this. And to do that, we'd have to do the opposite, in fact. We have to tell it which functions we can call on a const instance of our type. And to do that, we write the word const after the end of the member function definition. This is all quite wordy, but an easier way to do it is just to look at it. So if we ignore that, we've just got the same as we did on the last slide. But if you think about it, when we're just having a look at 2 points to see whether they're equal, that doesn't modify either point. All we're doing is examining it to see whether it's the same as some other point. So we should be able to say, is a const point equal to some other const point? That's reasonable, right? So we want our equal to member function to be callable with const instances. And to do that, we put this word const on the end. Okay? So you have to tell it which functions you want callable with a const instance. And then, again, we have our same 2 data members as before.
sorry, can you repeat that point of concept level?
Okay, so you're familiar with having a const instance of a type. So if you say const int I equals 7, for example, you're declaring an int called I that you can never change after you've created it, after you've instantiated it in the terminology. So having const variables is a very powerful thing. It allows you to, well, in some cases, makes things more efficient, but more importantly than that, it's about correctness. It stops you changing things when you shouldn't be able to change things. So We can have a const int. There's no reason we shouldn't be able to have a const point. If we've declared our new data type called point, we should be able to have a const point. But we still want to check whether our const point is equal to some other point. Right, that's a reasonable thing to do, because we don't have to modify a point in order to see whether it's equal to something else. So we've got this equal to member function that takes some other point, and we want this member function to be callable on a const point. So to do that, we write the word const at the end of the declaration to say this function can be called on a const point. So yes, this const thing is something that's not used in a lot of other languages. It's something that's not quite unique to C++, but certainly a lot more heavily used in C++ than a lot of other languages. So
Is it like static in Java?
no.
Final.
No. So final, if I understand rightly, final in Java means you can't override that function in a derived class, right? Yeah? So that's not what const does. This is not about overriding functions. It's not about inheritance. This is about whether we can call this member function on a const version of point.
So if we left it out,
Yep.
and what would happen?
Then if you said, so if you had const point p equals something, const point q equals something else, and you tried to say p dot equal to q, the compiler would say, you can't do this, because you can't call this const member function. So it would be a compile time error.
Is this just to struct that the member function have this const modifier, or is that like applicable to anything in C++?
No, this is only for member functions. It's not for free functions. If you try writing consts on the end of a free function, it will tell you you can't do it. It will say, I don't understand what this means. So this trailing const is only for member functions.
And if you have a p that's not a const,
Yep.
you can still call
You
it.
can still call it, yes, absolutely. So that's a very important point. So if we had a p,
The question was?
sorry?
The question was?
Oh, sorry, yes. So yes, the point made, if you have a p that is not const, you can still call this function on it, right? So if we had just point p equals something, point q equals something, so neither of them are const, we could still say, is p equal to q?
So if your function equal to returns a boolean, is it possible that it returns const boolean?
You could, but that's not a great thing to do for reasons that will get us deep into the mire if I go into them today. But basically, when you return by value, this is not returning a reference, not returning a pointer, it's returning by value. You don't want to make the return value const. You just want it to be a plain thing. And the reason for that is because if it inhibits moving, basically, it can stop some optimizations. So this is, again, if you look on old documentation, so pre-C++ 11, they might recommend doing it, but C++ 11 changed things in some ways, so that basically when you return by value like this, you don't want it to be const. You don't want the return type to be const, that is. So, this is where it gets fun, right? Because all that was nice, all that was simple. Now it gets a bit head spinning. We can provide two versions of a function of the same member function, or member function with the same name, same return type, same arguments, but one of them is const and one of them is not const. Right? We can, in the terminology, overload on constness. So this is just an example. Now we have our equal to. It doesn't have the word const here. Now we've provided a second member function, which looks the same, except it's got this word const on the end.
There is another way of overloading.
Sorry?
There is another way of overloading if you were to change the number of parameters.
Yes. Yeah. But in this case, this is overloading on const. So these are two different functions. This is a perfectly fine thing to do. Right? In fact, it's quite a common thing to do. We're overloading on constness. And in fact, the declarations don't have to be identical. They're allowed to have different return types. They're allowed to have different argument lists if you really want to. The declarations don't have to be identical. In fact, returning a different type is quite common. So now, what happens? We've got these two overloaded equal to member functions. So now what happens is we have a const p, so const point p equals something. If we then say p dot equal to something else, because our p that we're calling it on was declared const, it's going to call this second one. It's going to call the const version of the member function. But if we then declare point p2 equals something, so now p2 is not const, and we say p2 equals something, it's going to call this first one. So this lets us do two different things depending on whether we're being called on a const instance or a non-const instance. Yeah?
When would that sort of thing be useful?
Good question. So the question was, when would this be useful? So if you want an example of this, have a look at standard vector. So it has, say, it's got a method called front. It's got a member function called front. And in fact, front has two different overloads. One is const and one is non-const. And the const one returns you a reference to const t, and the non-const one returns you a reference to t.
T is the thing that it's...
T being the type that vector's parameterized on. So the reason for that is if you've got a const vector and you call front on it, you shouldn't be able to modify the thing that's inside the vector because you declared it const in the first place, right? However, if your vector was mutable, that's non-const. If your vector is mutable, then you call front on it, then it returns you just a reference to the thing so that you can modify it.
Sorry, I don't follow. What happens if you call it on const version?
So in this example, if we have a const point and we call
No,
it...
on the vector, on the example that you gave about vectors.
It's the same principle as this. So if we have a const vector and we call dot front, so dot front gives you a reference to the first element in the vector, assuming it's not empty.
Oh, right, okay.
Yeah.
So it doesn't mutate it.
Well,
Yeah.
or it can.
I was thinking that front mutated the vector.
No, it returns you a reference to the thing inside it,
Okay.
to the first element of the vector. There's a corresponding dot back that returns you
Yeah.
a reference to the last thing in the vector. So that's an example of when this overloading on constness is useful.
In this case, do we really need to distinguish between const and non-const? I mean, it's an equal function.
That's a very, very good point. So,
This explains, I think.
so
The question was...
the observation was, do we really need, in this case, do we really need to write two versions of equal to? What do you think the answer is?
If you wrote it down, yes.
So we've had one person saying, well, I wrote it, so maybe yes.
You do, because otherwise you wouldn't be able to call that function on a constant instance otherwise. You do have the const declaration.
You just have the const declarations. Is it not?
So
I think it's
call it
related to
anything.
organization of the memory, so you need it.
no. In this case, you do not gain any advantage from writing this twice. Right? In this case, as I said a couple of times, checking whether two things are equal doesn't modify or even potentially modify our point. So we really don't need this first declaration at all. This was just an example to show you what this looks like, right? But and in fact, I'd say I wrote all these slides months ago, but I remember sitting there when I was writing it, going, I wonder if anybody's going to pick up on that, and you did. So that's really good. So it's, shows it's clicked. So well done.
So really, when you consider that, you really, if you're looking at 2 lines for that, or it really depends on the return. Whether you do a certain return,
Yes.
what you want to send back.
Yes.
That will determine whether you need both those. Is that a fundamental basic rule you can start considering?
Well, it's really about whether having const or not depends on whether the function needs to modify the type. And for some functions, it might modify or it might not. And in this case, equal to is never going to modify the point it's operating on, the point it's looking at, right? So we really don't need this first one. We only need the second one. But yes, you're right in that, for example, the vector front, the important difference is the return type.
Yeah. So, and if you're passing an immutable argument,
Yes.
and you don't want to mutate your return, you probably don't need to consider having
Yes.
not having the const or something like
Yes.
that. Yeah. Okay. Cool.
A quick point is that if your const function, right, is bound by the same rules as the caller, so your fields become const. So when you're in a const function, all of your own fields are now const as well. You can't violate. Well, there's a way you can, but by default they are const too.
Yes.
So sorry, I was saying that if you remove that const for the type and still put the const at the end,
Yes.
it will still equal to whatever we are considering.
So you're saying if we put the const at the beginning,
No, I mean, if you remove the const
yeah,
within the argument,
this one,
yeah,
yep,
and still put the const at the end.
yes,
Yeah. So it will still achieve the same function, functionality what we are trying to do.
No, because you can change reference.
I mean, like, it will still not be able to modify.
So if you removed this const word here, right, then within the body, within the definition of this function, you would not be able to modify the type you're operating on, what's called this. However, you would be able to modify the arguments. You would be able to modify other, because other would be a mutable reference.
Yeah, so this const is qualifying the other, inside const, and the outside const is qualifying the type.
Absolutely, 100%, yes. So the const in the argument list is saying we have a reference to a const point, so other is a reference to a const point, and this one on the outside is about ourselves, this, as it's called, the point that we're operating on, the point that this function belongs to. So if you thought C++ was simple,
Never thought that.
It can be learned in 21 days.
oh yeah, absolutely.
YouTube as it's now.
Mm-hmm. And then we have our members, our data members as usual. I even gave a little example, which would have been a lot easier with my hand waving, if only that had been on the bottom of my slides. I don't know if it's there. Can you all see this, by the way, at the bottom? So, Is that all right? Just about. So now we're declaring a point P, initializing it to 3 and 4. And we're now saying, is point P equal to this other? We're just creating a temporary here, another point, also with 3 and 4. Now here, P is not const. So when we say P dot equal to, it's going to call this first one. It's going to call the non-const version of equal to. But now we create a second one. We say const point CP. And now when we say CP dot equal to something else, it's going to call the second one because the instance that we're operating on is const. So that's how we declare functions. Now, we've talked quite a bit about the difference between declaring functions and defining functions. Have we not? About how when you write just a signature like that with a semicolon at the end, that's a declaration. Declarations have to go first, and then the definition can go somewhere else. It can go in a CPP file. That's the case for free functions. It's also the case for member functions. Right? We can separate the declaration of a member function. So the declaration of a member function always belongs inside the class. But we can write the definition elsewhere. So just like we can for non-member functions, for free functions, for the ones that we're familiar with, we can do the same for member functions. But in fact, for member functions, we can choose. We can write the definition inside the class, or we can put it elsewhere. We can choose which way we do it. So, again, it's one of these things that's easier to show than to hand-wavily do. So here we've got, just as we had before, this time I've dropped the non-const overload because, as was pointed out, it didn't bias anything, wasn't useful. So this is the declaration of an equal to function, equal to member function. Now, I've written a second member function called not equal to. And rather than putting the semicolon, we've got an opening brace. And just like a normal function body, we can just say it returns not whatever this returns. So this thing returns a bool. Well, not equal to should return the opposite of what equal to returns, right? So if it's true, if equal to returns true, not equal to returns false, and vice versa. So now, this member function is defined inside the class. This is only a declaration. So does that make sense that we can have separate declarations and definitions just as we can with regular functions? So now let's say, well, we want to write the definition. Somewhere we need the definition of the equal to function. Say, usually we put it in a CPP file. So the struct declaration would appear in a header so that we can reuse it. But the definition we put in a CPP file. When we want to write that, we can't just write, like we normally would for a free function, bool equal to arguments. Because you might have lots of different types that all have a member function called equal to. So we have to tell the compiler which equal to member we're defining. So we do that by writing the name of the type and then this double colon. So this is saying I'm defining this function equal to that belongs to point, which returns bool, which takes this parameter, and which is a const member function. And then we'd write our implementation. So this bit in the bottom, if I press space one more time, it's probably going to hide it. No, it actually worked. So this definition, you could put away in an implementation file, in a .cpp file. And this top part, the definition of the struct, would appear in a header file. So what's really common to do is for very simple functions like this one, you define them, you put the definition in your class. For member functions that are quite complicated, you hide the definition away in a CPP file. So, as I just said, pretend that says struct, otherwise we're just going to get deep into that rabbit hole again. So, as I just said, it's common, it's usual practice to put really simple member function definitions in the header inside the class. If everyone can still see. Yeah. This is, not sure whether to go into this too much detail now. When we put a function definition in a header, then that definition is seen in every time we compile a CPP file that includes that header. Right? So if you remember way back in, what was it, week 3 or something? We were here, weren't we? When we were talking about separate compilation, sending our CPP files separately to the compiler. What's going to happen is that if they all include a header, a particular header, and that header has the definition of a member function in it every time, then when the linker collects them all together, it's going to see multiple definitions of this same function. And it's going to complain and it's going to say, you can't do that more. I've already seen a definition of this in a different object file. To prevent that, there's this keyword inline. So you just write inline in front of the function. If that all seems a bit weird and mysterious, don't worry about it too much, because if you write your definition inside the class body, within the curly braces, inside your struct, then it's automatically inline.
Doesn't inline also have something to do with the way the compiler reads your code?
Once upon a time, it had to do with optimization. So if you declared a function as inline, then it would try to literally or almost literally copy and paste the body of that function into wherever you called it. These days, compilers are smart enough that they can inline or not, which is sometimes an optimization and sometimes not. So these days, compilers are smart enough to know whether or not that's an optimization and will do it automatically. And these days, the word inline is all about visibility and something called the one definition rule, which is kind of pretty advanced C++, really. So it doesn't really change the way the compiler reads your code, it's about the linker. So the linking stage happens later. And inline is about the linker. So, as I said, I prepared these slides quite a while ago, and had I done them today, I would probably have skipped that last one because it's not really important to know about today. Anyway, I've been wittering for ages. Let's do some work. So, hopefully, by now, you can all create a new project in C-Line. It does have this lovely function in the functionality in the menus that will create a new class for you, or a new. You can just change the keyword to struct. And it will create a .cpp and a .hpp file for you. I think it actually does .h by default, but it's the same thing. So your task basically is just to do exactly what I just did in the slides, but include, just write the definition of the equal to member. Just implement equal to that I skipped so far.
Good luck. What? Yeah, because he put a bell. And if someone's offering a bell, okay, let's see.
Are there any questions on that? Have there been any questions on that?
Yeah, we've just been asking questions. So I've been helping him. He still needs a sea lion license, doesn't he?
So mine expires in a week. I did, he said. Yes.
Did you get more?
I haven't even got there yet.
Yeah, this isn't the virus writing class, that's coming later.
Although is it a coincidence that your laptop said that and you're sitting next to Justin? I think not.
Yeah, don't trust that one. Bad news.
Okay, so yeah, so you create a new project, and then yeah, so if you click on
I reminded to fill out twice. So I would say saying that we need Ryan if we are together this stuff. There's open source stuff we can use. Take it
created, so see how it's created.
It says this one is not belongs to any project.
Yep.
So you need to include it. Why? So we're not really using Struct.
You can, so by default, C-Line names this thing, it says class points. You just create it, turn that into struct points.
Screw it, I'll just write the
Is that not accepted? You propose the bear, just say.
Yeah, but actually,
Vive la France.
Did this go well?
No, still on there.
Belgium shall win. Shall come.
That's alright. If France wins and they come up against us, we'll make you surrender.
Assuming that England goes forward tomorrow.
Precisely, we're against Croatia, right?
Croatia's pretty strong.
They are very good, yeah, so I've heard. We'll see.
Oh,
Give me an opportunity to refuel while you guys listen.
that's
Oh,
right. I'm just reading the instructions.
You don't want a beer, do you? Oh, booze at the back and soft drinks.
Allows you to create a new class.
Still plenty of pizza and booze and soft drinks there. Drinks there, pizza's there in the adjacent room.
So, C++ class, and what is that?
Point, and then you're halfway down the page. Functions.
It's good programming practice when you're passing by reference to always pass by const reference.
Yeah.
Yeah, we went through that.
Yes, unless you need to modify the argument that's being passed to you, then yes.
So wait, if I use that method for creating a new class in CLion, I get a point CPP file and a point H file.
Mhm.
You mentioned earlier that the class, or the struct rather, I'll use the struct.
Yep.
Goes in the header file. What goes in the CPP file?
So I want you to, this is the fourth bullet point, so I want you to put the declaration of equal to in the header in the class, in the point struct. I want to write the definition of equal to in this point.cpp. In hindsight, I could have written these instructions a bit more clearly.
Okay.
So just as a wall of text like that. I figured you're getting quite experienced with these now, so I okay, I don't know Visual Studio, but it probably has a way to generate a C++ class. Or write your own, yeah.
Or I could just use Notepad++ and then just compile the command line.
Either way, if you're comfortable enough doing that, that's yeah. It's an easy enough way to do it. You sound like you really know what you're doing, so.
I reckon it's going to be like some really interesting things, like so yeah, like coding practices that you just tend to overlook. Yeah, so. Like for instance, like unions, which is
I'm not sure that we will talk about unions because they're very tricky and error prone in C++ because you can easily get into undefined behavior and doing bad things and reading from memory you shouldn't be able to read from and things like that.
Usage of macros to define, not to define, to make out which data member you want to.
Exactly. So this in C they have all these things. So C++ 17 has this new class called standard variant, which is basically a much safer version of a union. So just as we have vector, which is in the standard library, is a sort of easier to use version of an array that automatically expands for you and manages the memory for you, standard variant is a version of a union that prevents you or makes it a lot harder to get into bad situations that you can with your language unions.
But each data variable still writes data like thing, you call it, still writes the same block of memory.
Yeah. They're all the data members are overlapping. Yeah. In union, that is, yeah.
feel at least.
Probably not, because to be honest, I still haven't got around to reading it. It's actually on my shelf. I haven't actually read it. So
I remember.
Laurent was asking about that quite a while ago. Laurent, who's following the football.
Who's the
This chap.
one?
You were asking about the Gang of Four and design patterns quite a while ago, weren't you? I still haven't read it. No. I don't know, because it's 95, isn't it? So it's quite old. So I don't know
Still relevant.
how many of them are still relevant. But it's
I think I could do them.
Yeah.
Like I even saw them apply to JavaScript.
oh really?
Yeah.
Oh.
So that was pretty.
Yeah.
Interesting. So.
It's one of those sort of classic programming books that everyone should read, and I embarrassingly haven't. It's a book called Design Patterns by, I can't actually remember the author's names, but they're known universally as the Gang of Four. It's all about object-orientated design patterns, observers and visitors and things like that.
It's Eric Dahmer and Richard Galvin.
Yes, that rings a bell. Yeah.
Do you have to name the point in equal to? So the const point and then a name?
So if you recall, the name is optional.
Sure, but if you want to use it,
Then
like
you have to give it a name.
So you
yes.
do have to give it a name.
Yeah.
Okay. Cool. My this is not resolving. Right. So my this is not resolving, and I don't understand why.
Okay.
So I don't know if I've got something that's wrong, or if I'm not doing, if it's because I haven't done anything.
No.
Yet.
Not the problem is not making us CPP. So, can I just look at your point?
Yeah.
Okay, so we've declared this equal to function. Probably the proper way to say it's not implemented. Okay, so now let's flip back to point.cpp.
Okay.
Okay.
I've included point 8.
Yeah. So what if I had another class called float point that had two members that were floatx and floatby, and that also had an equal to member function. Then somewhere in the left,
The float x and float y.
never mind, forget it. The point is you have to put point code on code in front of equal to. You have to tell it.
Oh, I knew when you said that, I knew I was going to forget that.
Yeah.
Right. Points.
So
Was not declared in yes, it was equal to.
it's a very slight difference in your definitions.
Point.
Yeah.
So then I just need to implement it in name.
Or in your font.
What do you mean?
Oh,
I
right.
thought I had to.
Oh,
implement
to use
in
it,
yeah.
to use it, yes.
So I've done. That's everything that I need to do in point. Wait a second, that's wrong. yourself against the other one.
Structured type.
Okay, so with this in C++, this is a pointer. So you have to do this and then arrow.
What do you have?
So rather than the dot, click the dot, put a dash, and then that's the one. But you can in fact just delete all of that bit and just say X.
Oh, right, okay.
That's what I meant by without qualification.
No, I still with this, initialize this is I don't know how to express.
You can just say equal to.
Yes.
Because inside this function, it knows it belongs to the point class. So within that, everything that's in the point class is available to you,
What do you prefer?
including other memory functions, such as not as such as
Preprocessors, if not defined, or pragma, like, is it just really just preference?
Pragma is technically speaking not cross-platform. So whereas if is Pragma is specific to the compiler. I, however, prefer to avoid them entirely. I just generally avoid preprocessor macros entirely. So if I need one, if I absolutely must use a preprocessor for a given case, then I will. But generally, I prefer to avoid using them as much as possible. So
that struct looks fine, but you don't include so
why would I need a preprocessor for
you
that?
don't include a C.
Are you talking about header guards?
Yes.
Okay, so that is just, you can either use Pragma once,
Yes.
or you can use if def some symbol, if end def some symbol, blah blah blah.
Absolutely.
For that one,
Okay. Is the P?
I generally use Pragma once
P to Y.
because it's pretty much accepted everywhere.
Is that?
There's a caveat to it, which is that if you use the if end def method, so if not there, find some symbol, define the symbol, declare the header. If someone's silly and they copy the file, then if they include that file elsewhere,
What we want to do is to
it's not going to include the same thing again because it's going to match that symbol. If you use Pragma once, that's based on just the file system, right? It goes, have we included this specific file before? So if someone goes and copies it, they can then go and include both of them. People shouldn't do that, and I don't expect someone to ever do that, so I just use Pragma.
Yes. So we've been using this ID called C-line. So it has a free 30-day
I use the header guards. Then that's just out of habit.
I think
If and def is fine. I think many IDs by default will generate that for you as well, rather than using Pragma once.
Got rid of the specs.
What's wrong?
They got rid of specs.
They've got no more bets.
Yes. Do I need to declare a constructor of some sort because it's not compiling?
Let me come and have a look.
go to github.com.
So I have a slash.
And then this
What?
What's wrong? Yeah.
Step like
Yeah. Well, when I'm texting, you know, I can do always this.
So that will give you some instructions on how to.
it's not so.
See, I'm still.
Okay.
Well, I didn't get P1x equals P2x.
Okay.
And then I need to pass a P1 and P2, which wasn't in the original call.
So what we're doing, so it's a member function, so it operates on the type, on a point.
Yeah.
Okay, so within the member function, if we just say x and y, we're referring to our. So you imagine we've got this, you can think of it almost, if you like, as we're being passed an extra hidden argument that is the type we're operating on.
Yeah.
Okay, and within the function that's called this.
Okay. Yeah.
So, but what you can do is just, well, no, just delete P1 dot. And the dot as well, yeah. And then,
Equals y.
no, and this thing is called P, so I'll just say P dot y, P dot x. So,
Okay.
okay,
And P dot y.
and then the same for P dot y equals y. Okay.
Right.
Otherwise, I'm just a bit confused as to why that is shaded.
Something else. Maybe it's just.
But that is correct. So now P dot x means the x that belongs to the
Yeah.
and the one without the initial thing is the one is the x that belongs to us.
Oh,
That's the
okay,
point
right. So that was hence we were, when we were calling it, we call P is not equal to. So that's
Yes.
1 and that's 0.2.
Absolutely.
Okay,
Perfect.
sorry, I was very slow.
No worries. If things are unclear, then it's my fault.
No. Sorry.
Values always show up as 0 or 1. Is there like a literal truth?
There is a way to do it. Do you want to know it? Yes. Okay. After this first double arrow,
After it, you're on Xcode 8.
type this. std : bool alpha. And then another double arrow. And that sets the output stream to write Boolean values as alphanumeric. And it probably will not compile.
There you go. Alright. So if I then change it to 1.
Yay! Awesome.
Just do 4,4. So I'm not linking point, and then I need to link the class back to the function, don't I?
So if we just go to point.cpp.
Yeah.
Okay, those all look fine to me. Yeah. So now in main, we want to create. So you don't need that line.
So when you use a Mac, it defines
So
C++,
now we
but
want to
it's
just create a
fake.
couple of
It
points.
actually just calls playing.
P and Q. So like you would for an int, but just create points instead.
That's fine. If you just update Xcode, it should work.
5 minutes.
Well, it's going to have two.
No, so if you were creating an int, you'd say int I equals 3.
Yeah.
Or if you're creating a string, you'd say string s equals
Yeah.
3. So what we want to do is create points.
Okay.
Very obvious.
All right. Okay. Point.
Line.
It's say 4.4.
Yeah.
Right.
Now we just create a second one as well, called it Q.
So Q. That's 3.
Also, I think I said this in Java, right? That the
Yes. It's pretty
Say
simple.
P dot I think I've missed like 3 lessons, so I'm not familiar again.
Ricky answered. He didn't manage to click it.
Yeah.
Okay, what?
So I thought I had to link
Ricky?
Yeah.
this class. It's just because I work.
Okay, so here, so main is not a class, main is just a class.
Right. Okay.
So one of these strings. Yeah, you can do this.
STD.
property is this, if the two x properties are the same and the two y properties are the same.
STD colon.
So you
That should say true.
Okay. Oh, yeah, it was that final piece of the jigsaw. Yeah. Okay. Cool. Thank you very much. That makes a lot more sense now.
Are you getting
point
I am getting hope.
Alright.
No. No one's
So you need to check that your
That's fine.
that your
Getting that round.
that your
Yeah.
no,
So you need to do it.
int a and your y is equal to y.
Some other function
If don't give me wins, we can still get the back.
It's not px though.
Oh, you're not taking the bet then, I take it.
If you want to
You have to decide before
We
it
have.
goes
That you define in your point.
no decisions in
So you just
Well,
say
I suggest the sort of I mean, we can reverse. If we can reverse, if
Okay, no
person
bet.
wins,
No
you
bet.
get
oh, I think
10
it's because you
pounds.
write x, don't just write point x, just write x.
Nah.
okay.
Because no, because you define x and
But
call
half
it
the time,
y
yeah.
is getting y. So when you're defining the function as a member of the
Actually, yeah. How many of the Belgians
anytime you refer
are
to
French?
x or y,
Yeah,
and then
French
it goes
speakers.
to functions, it knows that you're referring to the x or y on that instance. And
Belgium is
So
quite
do
good.
exactly that.
Oh, do you want to take the bet and change it?
Sessions,
You need to determine.
not the shots. Based on that.
You need to determine that equal to the x and the other x
Oh, so that's
and the y and the other y are equal.
Hear that.
Okay.
So x is equal to other x and y is equal to other x. So right, yeah. So you get y is other dot one. You need to return that return x. And
Six is where the function could be equal to we would touch the planet. Three
if you and with the inline this inline takes the next one. Someone tries to take that away.
I don't bother
We
with
didn't
inline.
like that one. I got like just okay, cool.
With lots of houses.
Yeah.
So you didn't need to use the word inline for the header.
I didn't bother with it. I just had
I just have
equal to equal to. So I'll define the x. So in the struct, define the x, define the y, define the equal to.
Yep. So this
define
declares
not equal to.
because it's inside these
And then complaining that function is not equal to. I haven't used it. And yeah, and then the point dot
Just stop.
takes that box argument.
equal to
Touch it.
declare find actually. Yeah.
Now,
these are
right, and the second declaration is
So can you
main.
help me a bit later on
I'm just
setting the
creating
roots on my books on my VM? Routing to the
Oh, Chris, show me that. So that if I take all out away,
yeah, you press internet. Are you on the VPN? You should get the
Take the blue alpha out.
I don't know why you can my flag here.
You can see that my last call said false down.
Or you can
Alpha out.
Today,
And then the booleans all appear inside 0 or 1. So this is so you just get a 0 or 1 for booleans, but that bool alpha makes it so it's like
We've got lots of
Have you seen this?
CDP files that include this header. They all know about what you know how many members it's got. They know what
Intel had a bug bounty or gave somebody bug bounty of 100k.
this tells you everything you need to know about
Yep.
the class point.
Just Intel had a bounty of 100,000.
So now in the CDP file,
Public information is on Intel's website.
It's on HackerOne.
yeah, I thought this part,
Is that not Intel's website?
That's
this part should be
Public information. Yeah, where do they get the information from?
It's actually stuff we've been using.
Where do they get the information from?
It's just we're making it ourselves.
yeah, exactly. It's just like
Just
anything, isn't it?
as soon as STD, that's all me.
It's just all what we do.
Yeah, it's just a daily job.
So now we want, this is the declaration. Right, we want to put the definition in. So let's wait. Still
Justin?
these words.
free cap. Free cap.
So now what we're saying, we're going to give it a function that's equal to and belongs to a class point. Points.
Yeah, so you start.
So that's how we write the declaration. So then you have to think about how to actually check whether when a point A and B equals true, how to check whether two points.
If you did this with places, it would say put this divided twice, while it's in my rows basically it's
So we're missing using
Came up and I used the
Yeah, same. So I was like, wait. Okay, so guys, if I was to call, if I've got my struct, I've got two values I can use in my point. But if I want to, if I say,
now we
I
have to
don't know, I
imagine
have
we've got a point.
an equal to, or not equal to function in the struct.
Is that equal
If
to
I have a max mean somewhere floating around outside,
so our point
without
two members
declaring it is, I
on
can
the
say
point
I can't use point P as max mean.
So we want to say is our
And you
x
want max min.
So say if I have, so here I have these two sitting here, which means if I use my point function, my point struct, and give it two numbers, it can sort that out. If I have another somewhere else, I have a max min,
Between a max min.
max, so STD max,
Stood max, yeah.
stood max.
You can't pass it a point.
I can't pass it.
No, it doesn't
But
know
if I put if I put a max
member function.
member function in there, then
You would,
it would work.
the idea, that's encapsulation. That's the content encapsulation. Your struct knows what it holds, and therefore it should know or it should know what to do with its own types, and therefore if it offers a max, it will take care of passing stood max and the correct stuff. Which is also why it's more advanced. This equal to, not equal to, what you would actually do an
uses the same compiler.
you would implement your own operator equals and your own operator
Okay.
exclamation mark. And that way when someone's using a struct, they can just type equals if A equals B. They don't have to call equal to, they can literally just do if A equals B.
Okay, right, yeah.
And the compiler will invoke that member function. This is obviously simpler.
Yeah. No, it's good because it's not something I've come across before. So it's a really nice way of keeping control of what people can use your functions for.
And this is why you would also use a class. So you would have a class. You don't have to have a class. You could just declare X and Y as private, and then no one outside of the struct can touch them. They can call your public functions, and now they're allowed to then interact with the structs through those functions. They can't directly access it. The whole point of object-oriented programming is that the class should be responsible for its own content, and it will offer ways for users to manipulate that content through its functions. They have no way of directly touching its own stuff. The class will always manage its own its own
Okay,
fields.
yeah.
That also, because obviously if you want to update it or change the behaviour, there's one place where you go, and that's the struct. Nobody else can touch anything else, right? Struct defines the agent.
Okay.
So I got a
Oh, there's a goal.
So if I so I don't actually.
Did you take that bet? I can't remember.
So does it matter what I define X and Y then?
No, you can put. I mean, the order in which you put them. They are public, so something can touch those. And I can create a point and then touch those X and Y. You may be private. I can't.
So this is what I've got in this, like, this is what I've done. I got a true and false return, and then that was definitely a logic there.
And that means that it's private.
They've overloaded operators.
X and Y.
Yep.
So,
You overloaded the operators.
Yeah.
Really? So yeah, I declared the member functions in the struct as you would. Then I defined them in my key,
Oh, I see those.
and I just get that.
Wait, show me the code.
Yeah, we did
Well, it returns like the right values.
No, but the point is that you're meant to compare your fields to those of other. You're just comparing your own fields, ignoring its parameter.
I meant to compare my fields.
You're meant to see if your point yourself is equal to the other point, and then nowhere in this case you actually touch or utilise this very
Standing on the side.
if my x is equal to the other one, then say if my y is equal to the other one.
YouTube. I just need to make a front end facing
Oh, so you just you need to find two.
Because what I've done is
Okay, so this would this is obviously guaranteed to return true. In terms of what I've said to you, yes, to truly test it, you should compare two separate points and compare each other. But in terms of what you need to improve,
That was a good one.
I need two objects of that.
truly test it, but in terms of
Extensions of the
to test it, to implement it. It should still look that way. It doesn't know that when you call it, and it should still perform the same comparison. So you need to compare my x to other x and my y to other
So
x.
then I create another instantiation of that
You
struct.
can, but that's not the problem. The problem is in point or CGP. You're not doing what you need to. You're just comparing your x to your own y. You need to compare your x to others' x, and your y
Oh,
to
right,
others'
okay,
x.
so then I'll just change the condition
Yeah?
if condition.
But also, the point is you return whether it matches or not. You just return the follows every time.
I'll do that then.
Okay, I'm sorry.
It did work.
It did?
Yeah.
Oh, good.
If I take my chair back.
So it has nothing to do with sex code.
No.
I think you took my beer.
So,
I
so
don't.
just for my
This is mine.
on the Mac, when you're using G++,
Yes.
underneath it's calling who?
Clang. Okay, so years ago, Apple used to supply GCC or G++, and then at some point, for various reasons, they changed to using Clang. But on the Mac, the G++ command, they couldn't take it away because lots of people's build scripts relied on it. So on the Mac, if you just call G++, it will actually call Clang, so it's a bit misleading. But you are using the Clang compiler. But for this, it really doesn't matter. This is quite sort of...
G++ -v, you will see that it will.
Yeah, so if you D++-V will actually tell you, it'll say you're using Clang version 702 or something like that.
This is not equal to.
Oh, it does. It says line 700. And this thing, 700, is the current version,
It's the latest available for, yes,
and the C line is underneath doing the same thing.
yes.
Good.
Okay. That I think people found quite challenging. Yeah. Which. No, that's fine. So I'm going to hopefully, although it's always a bit of a mess when I try and do this, so hopefully actually try and do this for you live. We may have to do funny things with the stream. These guys are watching a stream, but it's not our stream.
No, I'm not watching.
Can you guess which stream they're watching?
I have no interest in them.
All right, let's see whether I can. Okay. Can we see this on the online?
Yeah, I think so. Yeah.
All right. Woohoo. Right, having just gone into presentation mode, I'm going to exit it again. So hopefully you all just set up a default project. It looks something like this. So we can create a new C++ class. Call it point. Create a .cpp and a .hpp. I think that defaults to cpp and .h, but I changed defaults. Yeah. Tell it to do that. It's created these two new files. It gives you this warning, I don't know why. It'll go away in a second. What's not doing it?
Not in full screen, right?
I'm not in full screen, I'm just windowed. I don't know. We're having streaming problems, as often happens whenever I try and switch to this, so bear with us a second, sorry. Well, I can't.
Use it on a different desktop.
No.
Regular desktop.
That one, there's nothing on it.
Are you sure?
Yes.
Right click it, show window.
No available windows.
Yeah. We're going to restart the stream.
I mean, it could be that it's just C-Line's keeping it so busy updating symbols. Technology. Sorry? Yeah, well, you can probably hear the fans on my laptop going mad as well. There we are.
Infinity.
Right.
Okay, we should be back shortly. To update. Good.
Yay! All right, we're back. Right. So this is now got point.cpp, point.hpp. First things first. We'll change that to struct. So we've got a struct, it's called point. We're giving it two member variables called x and y, both of type int, and both with a default value of 0. So now what we want to do is to add, oh, if I can type, so now we have a member function called equal to. It's of type bool. Sorry, it returns type bool, and it takes one argument, which is a reference to a consequence. Okay, so I think most of you got this far. You don't have to. It's optional. It's sort of gives information about what that argument should be. But in the declaration, it's optional. So I've just called it other. So function equal to is not implemented. If you really fancy, you can generate a definition for function equal to. I'm actually not going to do that because it's cheating. So we now go to our point.cpp file. You see it's included point.hpp for us. So now I'm writing a function definition. Well, I am. But this isn't quite right. This is declaring a free function called equal to. What I want to do is to say, no, I'm defining the equal to that belongs to class point. Okay, so this member function, this function belongs to class point. And to do that, struct point here. To do that, I have to put point : equal to. So this is the equal to function that belongs to point. That's exactly what it is, yes. Yeah. So now you can see that this warning we had, C-line was giving us that it was not implemented. It's gone away because now I have implemented it. Or I haven't finished implementing it.
Question. Do we have to initialize the members variable in this way?
It's always good practice to make sure all your members are initialized. And there are various ways to do that, which one of them is using
the answer to the question is, strictly speaking, the language does not force you to. Generally speaking, you should, because you can nasty bugs if you don't.
Okay, so within our equal to function, we want to compare whether our point, the point we're operating on, the point that equal to is being called on, is equal to some other point over here. So conceptually, we've got 2 points going on. We've got us, and we've got this other one called other. So what we want to do is we can say if our member variable x is equal to other's member variable x, and our y equal to other's y, then we return true. Otherwise we return false. So remember way back in the beginning I said within a member function you can use the names of your member variables without qualification. I just meant you can just write x there, and if you write x without anything in front of it, it knows within your member function, it knows you're referring to your points x. Now if you want to make it explicit, you can do it like this, like this, with this. There's a keyword this, which is actually a pointer to the current instance. But you don't need to do that. You can omit it, and it works just as well. It's rare that you need it. Let's put it that way. Very occasionally, it might be better. It's not, well, there are a couple of times where you do need it, but that's rare. Sometimes it can be good for disambiguation. because, for example, if you had a global variable called x up here, then you'd want to make it clear that we're referring to our version of x and not the global variable. The global variables are a bad idea anyway, so.
It was just x appearing.
Yeah, yes, but the point is, it's because we're within a member function. Now, this is highlighted in C line. It's saying this expression can be simplified, and it can. In fact, we can just be really lazy. Oh, yeah. Sorry. We can do it all in one line. So now this expression here is going to return us a bool. So if x is equal to other.x and y is equal to other.y, if that's true, we return true. If this is false, we return false. So it's exactly the same as what I wrote before with the if and the else. It's just collapsed all into one line.
Makes sense.
So
It's that the result of x equals other dot x is either true or false, and the result of y equals other dot y is either true or false. So we're saying if, for example, so true and true is just true. True and false is obviously false because they have to both be true. So the result of the expression is always a boolean, and we return a boolean, so that works fine.
that one. Oh, like that. So you want yes.
It's in the language. It's part of the language. In your own member function, the word "this" is a special keyword. It's part of the language, and it's always a pointer due to archaic reasons, which is that references weren't actually invented yet. References came after, so because of that, we'd already said, well, we can have member functions and they're a pointer. References only came later. I'm sure if they'd have come first, this would have been a reference and not a pointer.
Right. So this thing is just setting our output stream so that it will display a boolean as either true or false rather than a 1 or a 0. It's just purely for display. So now let's create a point P, or not pointer. See how familiar I am with writing the word pointer. So now we're creating 2 points, P and Q. We're saying, is P equal to Q? So fingers crossed, when I build all this.
And so this was a question that I asked. Yeah. So you do create 2 struct objects.
For your test.
Where's it gone? Yeah. You can hear the... Okay, so you can see it's printed out false, which is exactly what we want because the point 1, 2 is not the same point as 3, 4. Right, so, but if I change this one to 1, 2, we build it again. then now P and Q are the same point, and equal to returns true. However, you know there's a however. This isn't very good practice. I'm missing something, or a couple of things. Because I'm creating P and Q, but I'm never modifying them. And if you never modify them, it's good practice to make things const. So now what's going to happen if I click this little play button? Can anybody tell me before I do it? Yeah, it's not going to compile. So you're absolutely right. It's not going to compile. And in fact, we get a nice warning from C-line saying non-const function equal to is called on a const object. So if we go back to our point definition, you see I didn't tell the compiler that this function could be called on a const object. So we need to put the const word after the function. No, it can act on both now. Okay, so now what's going to happen if I press the play button? Anybody guess? Sorry? You should be okay now. Any advance on should be okay now? There's a 50-50 chance, right?
Why, Alex, why not? It's going to link actually worse than
Yeah. So now if I press play, I'll get this little error saying out of line definition of equal to does not match any declaration it points.
very, very meaningful for a newbie.
Yeah. But this second one is a bit more helpful. Member declaration does not match because it is const qualified. Yeah. So if we look, our definition has const at the end. Sorry, our declaration has const at the end, and this definition doesn't. So we have to put the matching const here. There. Line 7, column 13. Yeah. So the column. Exactly. So it's in fact just a link. You can go straight to it. Yeah. So, apart from Alex's errors, hopefully now, if I compile it, we can see that const point P at 1, 2 is equal to const point Q. But if I take away these two consts, if I try and call this just as we did before, sorry, my laptop's absolutely on fire trying to process all the streaming as well, so it's going very slowly. But you can see it all still works. So that wasn't all that I told you to do. I wanted you to put a second member function called not equal to. So let's write that now. Okay, so it's not implemented, obviously. So this time we're going to write the definition inside the class. So rather than doing it separately, in the in the CPP file. Just as an example, we're going to show you how to do it inside the class. So what's a reasonable definition of not equal to? We've written an equal to. What should not equal to do? It should return the opposite. So equal to, need the return statement in there. So equal to returns where the 2 points are equal. So not equal to returns the opposite. That's what the exclamation mark does. It's not. Justin's looking at this going, that's not going to work. Yeah. Here. If I had written it down here, I would need to, but if it's defined in the class, then inline is implicit. However, this isn't going to work, but that's not why this isn't going to work. So if I try and run this now, might need me to actually call that not equal to function to show you what the error is. Oh, yeah. So now we're calling this not equal to function. And, it is working. However, what I was trying to demonstrate was that you need to say const on here, but I got it the wrong way around, sorry. Your not equal to function should of course be const when the other one is const. So then we can go back to main and we can say const here and const there. And hopefully this will say false and true if it ever finishes compiling. There we are. And if we really want to reassure ourselves that it's working, alrighty. Whew. So our point doesn't have any constructors, so it's what's called an aggregate. Oh, right. Yeah, so the initial idea was I was going to talk about constructors today, but we're not going to have time. So we'll talk about constructors next week. But in this case, because it's a very simple, it's what's called an aggregate, so you just initialize the members in their declaration. So, yeah. Right, woo! Look at that. Yeah.
But it is the case though, that in explicit constructing, you don't use an explicit keyword when the constructor only has one argument.
Correct, yeah.
And that's because to stop it from being
from being used for implicit conversions. So, but we'll get into constructors. Well, next week now, because we're not going to have time to talk about constructors today, but we will just about possibly have time to talk about operator overloading, or at least briefly talk about operator overloading. Sorry? Yeah, how hard can it be?
Not at all.
So, when we have built-in types, we have ints and we have floats and chars and doubles and those things. We can use
mathematical operators. We can say 3 plus 4 to add 2x. Right? We can say, if we've got 2 ints, we can say x equals y to test whether they're the same. In fact, we just did that. Wouldn't it be nice if for our own types we could also use these natural operators? If I've got a point P and a point Q, well, mathematically, I could say what's P plus Q. It will give me another point over here somewhere. Now, I could do that by writing a member function called add. But it'd be nicer if I could just say plus. We've just written member functions called equal to and not equal to. But it would be much nicer if I could just say P equals Q. Like I can for ints, like I can for floats, like I can for built-in types. And in fact, C++ does let you do that. It lets you implement these mathematical operators for your own types. And that's something called operator overloading. Now, not all languages let you do that, and in fact, some people hate it. But this is C++, you are allowed to do it. And the idea is that it makes your own data types hopefully behave like built-in types do. So C++ allows us to provide operator overloads for our custom types. So, to do that, I define a function called operator equals equals. So if you think about equals equals, it's got to have 2 arguments. It has to have a thing on the left and a thing on the right. So this is now not a member function. This is a free function, a non-member function. You say bool, because if you're testing whether 2 things are equal, that's true or false, right? So bool, operator equals equals, and then we have a P and we have a Q.
Is operator a keyword? Operator's a keyword.
Operator's a keyword, yes. So this whole thing, this is operator equals equals. So we can't, if we just left out the word operator there, it would get very confused. So we're saying we're implementing an operator, and that operator is called equals equals. And if we write this function, we implement this function, we can use it to compare 2 points using the natural equals equals, like we can for ints, like we can for floats, for whatever built-in type.
Quick thing to mention as well is that if you think about what your equals equals is, right? You just do if A equals B. There's a left-hand side and a right-hand side of that equals equals, right? A is on the left, B is on the right. That's what that P and Q represent. P is going to be what's on the left-hand side, and Q is going to be what's on the right-hand side.
Absolutely. So now we have our 2 points, P and Q. Oh, and they've disappeared, but we did have P and Q. And now we can write this. We can assert, if you remember the assert function from ages ago, it's a testing function that crashes your program if this thing is false. So now we can say P equals equals Q. And now the compiler will know that we want this function. So, almost all the operators in C++ can be overloaded. There are 2 exceptions, well, 3 exceptions. There are lots of operators that can be overloaded, okay? There's plus, minus, times, divide, modulus, XOR, logical and, logical not, but all of those, all of those, all of those, and all of those. There are lots and lots of operators that you can overload.
Scope resolution operator can't be overloaded. the conditional temporary operator can't be overloaded, and for its pointer to class one.
The dot. Yeah.
I'm quite surprised to see the assignment operator in that list. I was expecting that not to be invocable.
That's a very astute observation. So I was quite surprised to see the assignment operator, this single equals, is on the list. And in fact, that's a very, very special operator, the assignment operator. And in fact, overloading the assignment operator is so special that it gets its own set of slides much later on that we're not going to get to today, but so we'll do it next week instead. Yes, overloading the assignment is very special. But nonetheless, it is on the list, and we can and do sometimes overload it. Yes. So we can write our operator overloads either as member functions or as non-member functions. And just to make it really confusing, there are some that have to be member functions. So this one with the square brackets, this array index operator, if you think about when we access element number 5 in a vector, you put it in square brackets, it returns you the 5th element. That vector has an overloaded square brackets operator. This one must be a member function. There are possibly others that must be written as free functions, but I can't remember them off the top of my head.
Input operator and output operator must be non-member function. I mean, they must be written as non-member functions.
Where are they? These shift operators.
Input and output.
Well, for integers, they're bit shift operators, and if you use them as bit shift operators, they can be member functions. If you use them as streaming if you use them as streaming operators, yes, as we'll see in a minute. So if you write them as free functions, they take 2 arguments, a left-hand side and a right-hand side. Think about plus. We'll go with plus because it's easy. Plus is a binary operation. It takes 2 arguments. X plus y, left plus right. So if you write a free function that's an operator plus, it takes 2 arguments, the left and the right. But if you write it as a member, it takes 1 argument, because one of them is implied. It's this. It's the thing that we're a member of, that we're operating on. Mm-hmm.
So if you are overloading that, and that has some kind of built-in behavior, and is it possible that you're overloading into some kind of conflicting situation?
No, so you're not allowed to write, sorry, let me put it the other way around. You're only allowed to write operator overloads for your own custom types. You're not allowed to write a version of plus that takes 2 ints. Okay, that's not allowed. You can try and do it.
You can overload, let's say, a plus of 2 points in order to default points. Because we just defined this thing called a point.
Yeah. Not automatically, but you could write operator plus that takes 2 points.
Is that it? That's basically the most common use of operator overloading.
Yes, absolutely. Yes.
And you're just saying that I could have that plus overloading within the struct definition. It takes 1 argument,
Yes.
1 pointer, and the implicit other pointer is this.
Yes.
Or I can define this outside
Yes.
my point. But if I put it outside my point, where should that overloading function belong to? To my namespace or to my?
So that's a good question. So really, you're saying is where should I write this definition?
Yeah.
And the answer is do it immediately in your header file, write the definition in your header file immediately after your class. That's where it belongs. So the overloaded operator sort of morally is part of the class. Even if you write it outside, it's part of that class's behavior, right? So anybody who uses your class should know about the operator plus. So you put it in the header file, you put it immediately after the definition of your class.
I think there's a key point though to make is that if you put it outside, only do that if you have a really good reason and a necessity to. Because if you're writing a class where things are private, you would then have to make that free function a friend of the class to access its private internal. So always prefer operator overloading inside your struct or class. Only do it outside if you really have to, which is fairly rare.
So would an example of that be, for example, sort of like multiplying matrices is overloaded for a matrix?
Absolutely, great example,
In
yes.
graphics?
Yeah, so the example
Okay.
it wasn't picked up on the stream. For example, doing matrix multiplication. So you could overload the times. So you could have matrix A times matrix B, and that would do matrix multiplication.
Mathematical vectors.
Sorry?
If you have an actual mathematical vector.
Or mathematical vectors, another good example of when you want to overload a few of the mathematical operations. So plus and minus and things like that would make sense for vectors.
What if you want to use, I don't know if this is possible in C++, where this occurs in C++, but in some other languages I know operators such as the plus operator can be used as unary operators, not binary. So can you overload the plus as a unary operator?
Std string does just that.
Absolutely you can, yes. So again, the astute observation was that operator plus is an example. I just went ahead earlier and said, oh, it's a binary operation. You have a left and a right. But probably a better example is the minus, right? So minus, you say A minus B. It's a binary operation. But there's also a unary version of minus. That is a version of minus that takes one argument. Because if you say x equals minus y, and x and y are ints, that's saying x is equal to minus 3. It's equal to the negative of whatever you gave it. So in fact there are two versions of minus that we can overload. There's the binary version and the unary version. And indeed, yes, you can provide both of those overloads. And moreover, it's a very good idea. So if you do one, you really should do the other.
In Java, you almost always maneuver it so that you can, in essence, do something like a hash.
Yeah.
And then you can do the comparison with the hash.
Okay.
And that's really
In Java equals always compares the reference value. So that's the
Okay, it's
classic
identity.
mistake in Java, right? If you want to compare strings, you have to use dot equals, not equals. So it doesn't do what you actually want. In C++, you can just redefine what they mean, which means you can make them do stupid stuff. You could make plus actually subtract. The compiler doesn't care what you make it do. You can be sadistic.
Leads on very nicely to this bullet point here. Operator overloading opens the door to doing crazy things. This is one of the arguments that people have against operator overloading. Because I could define plus for my type, and I could make plus subtract things. I could make it divide things. I could make it print hello world or format your hard drive. There's no guarantee that plus actually adds things, right? But then there's no guarantee that if I write a function called add, there's no guarantee that that doesn't format your hard drive either. So all this is doing is giving familiar, recognizable names to functions. You can do stupid things in your operator overloads if you really want to. But then you can do stupid things in your functions anyway. But you shouldn't do stupid things. Of course you shouldn't do stupid things.
This operator overload, I presume it's not for large functions, is it? It's for
case of regulation small operations?
In general, yes. There's a sort of expectation that plus should be a relatively cheap operation, right? Or comparing two things for equality should be cheap. That said, something like matrix multiplication isn't necessarily going to be cheap. It can be very slow, time-consuming
Yeah, but it's not
thing to do.
lot of code.
Or matrix multiplication actually might be if you do it. They're very sophisticated techniques to do it, but yes. As I was saying, operator overloading opens the door to doing crazy things. Don't do crazy things. If you're going to overload operators, make them do the thing people expect. If you define an operator plus, make it add two things. If you define a minus, make it subtract things. Basic rule, do as the ints do. I think some people, either above us or below us, might be watching football.
No, it's the guys in the kitchen.
Well, France is one. I guess they're French then.
No, there's only one French guy.
Right. Anyway, do what the ints do is the golden rule. Right? It's the thing to bear in mind when you're defining operators. So for ints, plus adds them, minus subtracts them, star multiplies them. Sorry?
Comma for what's happening?
Don't ever overload the comma operator. Yes. Be sensible. Don't go against the expectations of users of your type. So one particularly useful application of operator overloading is the output stream operator. This is what you were saying. Go back one. Go back too far. Let's try again. So these operators here, these, for ints anyway, they're defined as bit shifting operators. They do really low level, as I say, bit shifting operations. But for output streams, these have overloads so that you can say standard out, arrow, arrow, hello world, as we did right at the beginning. Right, that's an example. I think Francis is. That's an example of operator overloading. And in fact, that's an example of doing something silly with your operator overloads, because I just told you to do what ints do, and when they wrote these iStream classes, they decided to give them operator overloads that did something that was nothing to do with bit shifting. They kind of redefined them as streaming operators. But that was 30 plus years ago, and I was barely alive, so I couldn't yell at them. So it's done now, and we have to live with it. And we may as well go along with it and write overloads of the streaming operators to allow us to print our own types. So if we're going to do that, this is, as you were pointing out, in order to use them as streams, we have to write them as non-member functions. Now, why is that? Can anybody? So it'd be a global operation. It will be a global operation. If we put it as a member function, it would still be visible to everybody who used our class. So it would still be global in that sense.
It's because the left-hand operand can't be modified.
You had your hand up.
Operand can't be modified, so they've got to be non-member functions. They're going to be defined as non-member functions. Who am I speaking to? But yeah, they can't be defined as non-member functions.
So, what I was saying, binary member functions have to have. So if you think about the streaming operator, you have cout on the left, and you have your thing on the right. You have a left and a right. Well, the left-hand thing is going to be the output stream.
And you can't add new member functions to the standard library's output stream. So the thing on the left is the type you're operating on. Well, you can't add new member functions to the standard library class, but you can add a new non-member function that's globally available. And we do that like this. So we write operator left arrows, double left arrow. And the first argument always looks like this. It's a standard O stream, an output stream, a mutable reference, and then the second argument is our type that we want to print. And just to meet the expectations of this protocol, we also have to return the O stream that we were given. That's what allows you to chain multiple arrow invocations together. So, here's what we're going to do inside it. We've been given our output stream. OS, I've called it. Now that's, for all our examples, we've used cout, but there are other types of output streams. You could have a file output stream, for example. Log output stream, whatever it may be. So we're going to have OS, and then we're going to pass it an opening bracket character. We're going to pass it p.x. So remember, we're just using the same definition of point that we have everywhere. We're going to pass p.x. We're going to put comma space, then p.y, and then a closing bracket. So we're going to print open bracket, x, comma, y, close brackets, which I think is a reasonable thing to print for a point, right? And then we need to return the output stream, because in order to chain these things together, we have to return the thing. And now if we do all that, we can print our points. And so what happens is when the compiler sees this, it sees this double arrow, it looks at the types on the left and the right and says, do I have a matching function? This thing is an example, this thing's an output stream, this thing is a point. Do I have a function that's a double arrow that has an output stream on the left and a point on the right? Can I match that to any functions? Yes, I can, because we've just written it and it's just disappeared because my slides are stupid. So, okay, it does that. And then that function returned us the output stream. So in place of this, we've now got the output stream again. So now it looks at it again. It says, do I have a function that's got an output stream on the left and a character on the right? Yes, it does, because it's built into the OStream type. So then it applies this function again, and that's how you can chain all these things together. So, we're done, almost. Just one more slide to go. Well, one more after this. Something to think about. We've got our point class. It's got two members, x and y. What operators does it make sense to overload for our point? So mathematically, you think about, you have a two-dimensional point. What are reasonable things to do with a point? Add and subtract 2 points. Yeah. So you have point A plus point B. Subtraction, is subtraction reasonable? I suppose so. Yeah, if you think about them as complex numbers, maybe.
You can overload the equivalence up and
Equals equals.
Yeah.
Yes, absolutely. That's a prime example. Yeah, definitely. So we wrote a member function that was called equal to, right? But instead we could just overload the equals equals operator, and then we wouldn't have to say p dot equal to y. We could just write p equals equals y the natural way. So yeah, equals equals is a good one. If we've got equals equals, what's the other thing we probably should have? Not equals. Yeah, absolutely. So this is where, if you're going to use operator overloading, really follow the expectations of the users. And the expectation is, if you have equals, better down multiply not equal to as well, right? Because otherwise people are going to be very, very surprised. So, yes, I agree. Equality comparison. addition and subtraction of 2 points, plus, minus, and if you're going to do plus and minus, probably plus equals and minus equals as well. One we didn't mention, but I'm sure you could just see would be useful, is streaming to standard O stream. What else? What else would be useful for a point?
Where O stream is most likely going to be C out, so you can read it on the console.
Yeah.
Comparison, but that's
Does it make sense to say, is this point greater than this point? Is that point greater than that?
reference to another third point. Yeah, because you have two. Yeah, because each one has two values, so it doesn't quite work.
I would say probably nothing else. These are the only ones that really logically make sense. Now you could, there's nothing to stop you writing a less than operator to say, is point A less than point B? But does it really make sense from a mathematical point of view? Probably not.
You'd have trouble.
Can you make your own operators rather than overload them?
No.
No, you can only use the ones that I put on that very big list, which is probably enough. Right. I know Swift lets you define your own operators.
I was just thinking that was getting polar coordinates or something like that.
There was a massive fight to try and get operator dot into the standard. And so no, you can't, and it's a fight even to get new ones added.
See, yes, you can do the stream from, so you'd reading from. So that would be a reasonable thing to overload as well. Yeah. So I had stream to stand O stream. You might want a corresponding reading from an I stream. Yeah, that's a good one. It's one I forgot. But yes, that's very good. All right. So I did have this exercise, but it's now 9:05, and you're all itching to go to the pub. I made this last just long enough that Laurent didn't get to see any of the football. So we'll pick this up next week, where we'll talk some more about structs and special member functions and this mysterious assignment operator. And then once we got through that, we will talk about classes. So thank you all for coming, and see you all next week, I hope.
That's homework.
Oh, well, you can make it homework if you like.
Are you going to load this on
GitHub.
On GitHub, yes, I will, yeah.
I need some practice after this class.
All right. Well, thanks very much, Tristan. Excellent
Thank
session as
you.
usual.
Can you ensure that obviously the place is